Hello, everybody. I hope you're all doing well. Welcome back to another episode of Blockchain and Beyond. As always, I'm your host, Farzan. On today's episode, we're going to be talking about VRFs, which are verifiable random functions. And today, I'm joined by a friend and also a guest who has appeared on this show before. He's a really smart guy. He knows a lot about Algorand, he knows a lot about maths and all of this fancy stuff. But hopefully, we're gonna break it down and make it easy for everyone to understand. So, I would like to welcome and introduce Bit to the show.
What an intro! Thank you very much. Thanks for having me back.
Yeah, no, it's a pleasure. We spoke quite a long time ago, and I think since then we've sort of kept in touch. We've been having a few conversations back and forth, and I thought it'd be a great place to have you back on since you're quite knowledgeable about all of these advanced topics, some of which the parts go over my head, but you seem to have a good grasp on it. So I guess we can start from the very basics. So what does VRF stand for, and what does it actually mean?
Right. So VRF stands for Verifiable Random Functions, and it is basically a way to have access to randomness on a blockchain. Um, Randomness on a blockchain is actually quite challenging because unlike when you're executing a program on your own computer where you can have access to some source of entropy, whether that is actually random or pseudo-random, that's kind of beyond the scope. Um, on the blockchain, the entire consensus participant party, let's say, has to agree on the a specific outcome of a smart contract call or something. So it needs to be deterministic. So we can't actually use any randomness. And another challenge is that it needs to have a component that is unpredictable. Otherwise, it wouldn't actually be random and people would be able to predict the outcome and game it, right? So also it's worth noting that VRF has a very special relationship to Algorand on the consensus level, as is heavily used in order to select which consensus participant is going to be proposing each block, and then who gets to vote on validating that that block is okay and we should accept it as the next head of the blockchain.
Yeah. So yeah, as you mentioned, I think the relationship between Algorand and verifiable random functions is quite unique, where VRFs are quite integrated or a crucial part to our consensus mechanism or the consensus mechanism in general. Whereas on other blockchains, the VRFs are potentially just an add-on to how the blockchain functions. But on Algorand, it's something which is crucial for the day-to-day operation of the VRFs. Um, do you want to talk a bit more about like where we might see VRFs before we dive into how they work a bit more?
Sure, and something else to touch upon is the difference between VRFs on Algorand and other chains, because it does exist on chains like Solana, but it's quite different and a lot more robust, I believe, on Algorand. But first, VRF would basically, I think most of the applications are going to be gaming related. So you can imagine something super simple like a coin flip, where heads or tails would dictate whether the user has won a wager or lost it. And in order to be able to access this from a smart contract to then pay the user or not, you'd need access to some randomness on chain. Should I go into? Yeah, I may as well. So the way this works is for in order to provide verifiable randomness, you need an off-chain component that's usually referred to as the VRF service, and an on-chain component that comes in the form of a smart contract. And it's callable by other smart contracts or end users themselves with a little bit of elbow grease to provide a randomness value that is actually quite big. It's usually 32 bytes. Not usually, it's always 32 bytes. So that's 2 to the power of 256, or 1 and then 76 zeros behind it. And then based on that value, you have to, as a smart contract developer, you have to convert that into the outcome that you want. I think we may have actually been the first project to use VRF on mainnet using a proper beacon. That was with the cup stakes, which I might come back to cover on another episode. We launched that 2 days after the Algorand mainnet beacon went live. So that was quite fun. And in our case, we mapped the randomness output of the VRF smart contract to a selection of a World Cup team. So in order to produce a random value and have it be verifiable so that it can't be gamed by either the provider of the VRF service or any of the block proposers, the way this works is using public key cryptography, but also using data that is generated on-chain and that it's really hard to game, essentially. So the VRF service that has access to a private key, the public key of which is given to an on-chain smart contract. Now, new randomness is seeded every 8 blocks currently, although that could be shorter. And the way this works is the off-chain service takes the block header of every 8th block and then signs it with the private key. And then it makes an application call to the on-chain VRF oracle, which then verifies that the correct private key has been used to sign the new value. And that is actually used to provide randomness to other smart contracts. Is that clear at all?
Yeah, I think I get that. So there's an off-chain part and an on-chain part. So the off-chain part actually creates or generates these numbers, and it will sign them, and then it will basically send them off to the smart contract, which is on-chain, and the smart contract will verify that it was sent by the off-chain oracle or producer, and then it will give access to other users or smart contracts to actually call and use these numbers.
Yes, but also the thing that they are signing comes from the chain itself. It's the block header of every 8th block. So on-chain, the smart contract not only validates that the correct service has signed the value that we're using, but it's the signature of the correct thing. So for example, the off-chain service couldn't just generate whatever they liked. It would have to be the block header of that particular block. And this is really interesting and pretty much a paradigm shift from the way we have come to accept randomness in online gaming in Web2, in that even the providers of the VRF function, if they knew that a specific round is going to be used as like a multi-million-dollar lottery payout or something, they can just make up whatever they like and publish the randomness that would make sure that they would win. Because of the fact that the block header is going to be used as the thing to be signed by the private key of the VRF service. And that can't be known in advance. So I think that's really, really exciting. And it's basically something that if it catches on, I think that maybe in 10 or 20 years' time, we'll be telling our kids that once upon a time we used to trust a black box backend to tell us what like Texas Hold'em cards we drew or what the digital roulette outcome was, and it will seem quite incredible.
Yeah, I think I can relate to that, and I think a lot of other people can, especially in the gaming sector, more traditional video games where loot boxes have become a lot more common, and these have a 8% chance of getting a specific item, and they publish statistics of the probability of you getting that rare item, but there's no way of verifying if that's actually true or not. You just have to trust whoever's hosting the game, that their numbers are accurate and in line with the numbers they have published. But with VRFs, it gives, everyone a way to actually verify these numbers for themselves so they can be sure that, the system hasn't been rigged, against them or in favor of someone else.
Yeah, that's exactly right. It is extremely hard to game something like this if it's implemented correctly. There are two very interesting articles published by the Foundation Algorand Inc. on the developer portal about how to actually consume randomness. And a key point that I think might be missed by a few developers if they haven't read that is that after the randomness has been published, it's public, right? You cannot rely on it anymore. So unfortunately, it's a bit cumbersome to actually implement this in a smart contract as a dApp developer, because you have to split the actions. You have to take payment and commit to a randomness round in advance before it's known. You can't really work around that, um, because otherwise users may only would only pay when they could calculate that they would win, like a malicious user, obviously. And so in the cupstakes example, we take a payment first and then we commit to the next randomness round before it's known. Otherwise, people would be able to predict what the outcome would be and draw the rarest themes every time.
Yeah, and currently that's, as you mentioned, it's a limitation of the current system where new numbers are sort of generated or presented every 8 rounds or every 8 blocks. And this can potentially change in the future where if this becomes much smaller, or if, for example, a new VRF was generated every single block, then you can effectively commit to the next block and you can get your number or your payout or your draw done immediately. Whereas I remember with while you were building cup stakes, there was the concept of you may have to wait, up to 40 seconds before you actually get to draw your cards, because it's not feasible to actually draw the cards in the current round because those numbers are actually public. And as you mentioned, a malicious user could actually use this to try pull some of the rarer cards. Um, so yeah, this is, I would say, one of the current limitations of the VRF implementation. But I think hopefully that will change in the future, and our round times or the number of rounds between new numbers will actually decrease, which will be quite useful for making a system which is much more user friendly.
The 8 block difference for each new randomness is fairly arbitrary. You could do that in 4 to begin with. It could definitely be made quicker.
So regarding the applications of this, we've mentioned a lot about gaming and, gambling websites online, whether that's poker or, traditional video games. What other areas could we see VRFs being implemented?
Really sure. The only stuff that I can think of is gaming related, really, because the other major part where randomness is used would be cryptography. But on chain, you don't actually do very much of that because you can't really use the store private keys on chain on a smart contract. So I can't really think of anything other than gaming related where you might want to use randomness inside a smart contract. Can you?
No, not really. The only other applications are, again, would be gaming related, but it would be like if you put all of your names into a hat and then you can use VRFs to actually draw whose name gets picked. That still falls very much under the gaming category, but that's sort of the main application I could think of. But I'm sure as time goes on, people will figure out new and like innovative ways to actually use this.
Yeah, quite right.
Is there anything else you want to talk about?
We could talk a little bit about what the difference is between VRF as implemented in Algorand versus Solana and other chains that do implement it.
Yeah.
And I think it's quite crucial. So, starting with the AVM V7, which was released in September, Algorand, the actual virtual machine of Algorand, now supports two operations that make a VRF Oracle a lot more robust and secure. And those are there's an opcode, as they're called, that gives you the block header, which is part of why it's actually hard to predict what the outcome will be, even if you are the VRF service yourself. And the other, which is the crucial one, is that there's a VRF verify opcode. So if on other chains you can implement a VRF function, a VRF smart contract, and basically just not really have any assurances that the developer of the VRF contract has actually done it correctly. On Algorand, there's the VRF verify opcode, which actually confirms that the VRF signature that is being submitted to the contract is, it's valid. So I think this gives an extra reassurance that the system is working as expected, and it's kind of legit, I guess.
Yeah, no, that's quite interesting. I never thought of that where, yeah, in the smart contract you can't be certain that, the developer has implemented it correctly. But if Algorand has a built-in way to actually verify this, then yeah, I guess that gives a lot more security, not only for developers to know that they've done it right, but also the end users who are actually using this to be a lot more confident when using these applications, that the person behind it has done their job properly, which I think is quite unique. Yeah, and I'm not aware of that on the other chains that offer VRFs.
That's right. And since you can have immutable smart contracts from a code point of view, you'd basically have to verify once that the smart contract that you're using for randomness is actually implementing the VRF verify opcode. And then, if it can't be updated, then you can trust that outcome so long as it's available.
Yeah, no, that's really intuitive, I would say. It seems like a really intuitive design, which you would think other blockchains would perhaps implement this as well. Perhaps in the future they may look at Algorand and see what they've done and begin to implement this on their own chains. Because I think that would be a lot better going forwards, just for the nature of smart contracts, where there's always a little bit of smoke and mirrors behind, is the smart contract properly written. But if there's a way where we can be certain of this small part of the smart contract being secure, then I think that's probably a step in the right direction towards more protected dApps for the end user.
Yeah, I think that's right.
So I'm quite conscious of time, of your time, especially. It is getting a little bit late. So first of all, I just wanted to say thank you for taking the time out to sit down with me again and talk about this. I think this technology is something it's something really new, and it's something that not many blockchains support, and I think a lot of blockchains will actually benefit from this sort of technology. So first off, thank you for coming down and sitting with me. Um, and secondly, like, where can people find out more about you, D13 Collective, what you guys do? Where's the best place to find you?
So my pleasure entirely to be here, and I do agree that this is a really exciting application of blockchain in general. I just hope it's going to be adopted and used in the future, and even improved, made faster, as we discussed. The best place to follow up on us would be our website at d13.co, d13.co, or our Twitter, d13_co. Thank you very much for having me, Farzan.
No, likewise. Yeah, thank you so much, and thank everybody to listening, and I will catch you all next time. So thank you and goodbye.